everyone. Hi, Abdul. How are you? Right? Okay, first I would have to mute you all because it's important. So let's see who all are here. Hello, Abdul Makid. Nice to see you again. I guess I get to see you in live sessions regularly rather than usual classes. And Abdul, hey, how are you? And is that Shazan or is that Shazan? Could you please turn your cameras on, everyone? That's amazing. Okay. Hi, Shazan. How are you? Hello, Yurid. Hello, Yvonne. All right. I would request you all to turn your cameras on, first of all. Okay, perfect. So, first of all, I would love to know who all are in year 11 right now. Shazan and Yurid, are you in year 11? No? Younger than that? Type down your ears. Oh, you're in year 10, all right. Yes, Abdul, I know about you. I know about Abdul Hafiz. You read, would you like to tell me about yours? And what about you, Yvonne? All right. Okay. So let's get started with our lesson today. First of all, for those who don't know, I don't know whether, like, I guess all of you would know about me, but just in case, if you do not know, I am Leva here, your science faculty at Glecta. All right. So I would welcome you all to Glecta, which is a tutoring platform for different classes, like be it from 11 plus to GCSEs to A levels, and different subjects are catered here, as you can see on the screen as well. Right. There's certain key features that we tend to follow that is there in Glecta, which includes that we would have highly interactive live sessions where you would constantly be talking and you would be, putting forward your doubts, your ideas, and everything. It would be like, open discussion throughout. These kind of sessions are the ones that we tend to provide. They're focused, like we would have small batches, not big batches would be there. All the preparation and practice is exam oriented. A detailed analysis of your report would be given. The qualified and experienced teachers. You will have weekly assignments to practice, and there are notes that would be provided for every topic. You would get recorded lessons, and we would work on your speed and accuracy as well. So, if I talk about Glecta is a one-stop solution where you would get notes, your practice tests, exams, lecture, and counseling session as well. All right. This time the topic is on chemistry. All right. So we are having a chemistry lesson today, which is on paper two. I believe the chemistry lesson paper two would be a bit difficult for Abdul. Would it be? Do you have any idea about what rate of reaction reversible reactions are? What do you think? It's for both the Abduls, Abdul Makit and Abdul Hafiz. And what about you, Shazin and Yurid? Have you covered any of these topics lately? If it is, do let me know. Oh, chemistry is easy, Abdul. Let's see. We would have different kind of questions to be covered. Type down, Shazin. What about you and Yurid? What about you? Oh, you know about rate of reaction. We would have a question that is on, hires. So it would go up to grade 8 level question in the class. Let's see if you would be able to do that. Okay, Abdul knows organic chemistry, light and colors. All right, you read. So let's get started with our lesson. First of all, the topics that we are going to cover here would be rate of reaction, reversible reactions, organic chemistry. These are the three topics that we tend to cover. I'll try to take, more of detailing of the concepts, and then questions would be sent to you. You would be taking those questions and trying them at your own, like, pace. And then make sure you're sending those questions to me so that I can check. Is that clear? All right. So the three things that are needed in the class again: your concentration. You should have a pen and a paper to make notes and solve questions, and your active participation. All right. Proper active participation would be needed during the session. There's certain goals that we need to attain in the end of the class, which is that we would be revising some of the topics in short in less time. We will learn how to write answers, and we need to be GCSEs ready already. Okay. These are the platforms where you can reach us, be it YouTube, if I talk about Instagram, WhatsApp, Facebook, or the other ones. So let's get started. First of all, we will learn about a basic difference between triple science and combined science. Shazan, like, are you in triple science or combined science? And you read, like, would you be opting for, you need to choose which science you would want to opt for when you would go into GCSEs for the ones who are still waiting to get into it, right? Do you know that? Do you want to? Okay, I'll tell you the difference. Shazan has triple science. That's good. There are certain differences in the topics in chemistry that we would cover. I'll be discussing about the difference in paper two topic. All right. So let's talk about rate of reaction and reversible reactions. Is there any difference? No, not really. That's why I have taken that topic to cater everyone. And I do have some more. Oh, okay, that's good. But do we have any difference in organic chemistry? Yes, we do. Like you need to know, yes, there is difference, like at this point, combined science would be a little lighter over triple science. I'll take marks on every section wherever you would want to work upon. Alkanes is a topic that is done in both triple science and combined science. Physical properties in both, fractional distillation in both, a bit idea about alkenes would be there in case of combined science, but alkenes would be covered in detail in triple science because you would have to learn about the reactions of alkenes as well, which is not there in combined science. Cracking is there in both of them. And if I would talk about alcohols, carboxylic acids, esters, and polymers, all of them are only there in case of triple science. So this is the area where combined science people would get some relief. They would not have to study about the last two topics and alkenes in detail, right? Now, we need to talk about the next topic in paper two, which is chemical analysis. In case of chemical analysis, yes, we do have a huge difference. Triple science students need to study a lot, whereas combined science students have to cover only a bit of it. All right. If I'll talk about triple science, all the topics would be covered. But in case of combined science, it's just the first, second, third, and fourth topic. You know what? This particular chapter can be done in one session for combined science. It's so easy. Like you just need to remember the points. That's it. All right. Let's move forward. Now we need to talk about the next topic, which is chemistry of atmosphere. We do not have any difference between the two. And if I would want to know about using resources, yes, there is. So, in case of using resources, if I would talk about in combined science, you just need to cover the first two topics. And in triple science, you would have to cover all four topics. These are the major differences that you tend to have in triple science and combined science for paper two. So, try to prepare yourself accordingly. Is that clear? For whichever you're going to choose for. If you're in combined science, don't waste time on learning other things which are not really asked in your paper. And if you're in triple science, you should know the importance. So let's get started with our rate of reaction topic, right? So the first thing that we need to talk about is rate of reaction. Quickly define what rate of reaction is in the chat box right now. I'll be waiting for your answers. Hey, Tawanga, it's good that you're here. Tawanga, would you turn your camera on? That's great. Okay, do you know what? We have just started with the topic and we're discussing everything. So, Tawanga, Shazan, you read. And even if Abdul Hafiz and Abdul Makid can answer this, quickly tell me what is the rate of reaction according to you. Ivan, you too can try. That's the formula, right? Abdul Makid, you would have to tell the rate of reaction like in sentence formation as well. Time taken for the reaction for the products. Is it products being used up, Shazan? Be careful. Exactly. It's not the time taken. You would not compare the time every time. Instead, you would say speed. All right. Change in reactants or products per unit time. Very good, Iman. And speed at which chemical reaction takes place. Exactly. Instead of talking in terms of time, you should say speed. So, speed at which your reactants are being consumed or your products are forming. So, quickly write that down in your notes, which is important, everyone. Rate of reaction is the speed, it's the speed at which what really happens? Reactants are consumed. Reactants are consumed, or your products are formed. All right, the formula is right there in front of you, although the formula sheet would be there in the paper, so they would provide you the formula. Now, there are a few important things that you need to learn for the paper. If you're sitting for your rate of reaction paper, what you need to take care of is you will have to know how to calculate rate of reaction using graphs. There would be two types of questions that would come up. One is calculating average rate of reaction, and the other one would be instantaneous rate of reaction. I'll try to show you. Isn't that difficult for you? Is it difficult, Abdul Hafiz and Abdul Makid, and you read if you're here? Is it difficult to understand or is it easy to understand? Oh, it's not. That's interesting. Okay. You will have to learn about collision theory. Before I'll discuss about the graphical part separately, but I want to know about collision theory. Who knows about it? I especially need answer from Tawanga's side if he knows about what collision theory is about. All right. All right, Abdul Makid. I need to know what collision theory is. Shazan, write your answer in the chat box. Abdul Makid, do you have any idea about collision theory? It might be covered in KS3s as well. You read, you too can answer it. Collision theory is covered in KS3 level as well because we are preparing them for GCSEs over there. The colliding atoms against container. Think about it. It's not particle theory. We are not talking about states of matter. Yeah, is it when temperature increases, collision increases? These are the factors that, on which collision theory depends on. You need to talk about what collision theory exactly says. Tawanga, theory used to predict the rate of reaction. Yeah, but what does it say? It predicts the rate of reaction. And then we need to talk about factors affecting rate of reaction or factors on which a collision theory could be dependent upon. Okay, I'll talk about what collision theory is first. When you talk about collision theory says that for a reaction to take place, particles need to collide. They need to collide. Your reactants are colliding with each other. And when they're colliding with each other, only then your reaction can occur. All right. Could you see that? If your reactants are not colliding, they would not form products. All right. First of all, collision is necessary. The first point, I'll be writing very smaller points on them. So please make sure you're writing it. Collision is necessary. Collision is necessary between reactants. But the point is, what kind of collisions? Do all collisions lead to reactions? What do you think? Say yes or no. Do all collision leads to reaction? Yeah, these are the factors, but you would have to tell me first collision theory in detail. Do all collisions lead to reaction? Yes or no? No, exactly. There would be certain collisions which would lead to reaction, there would be certain collisions which would result. Collisions which results in chemical reactions are called as effective collisions. Now, what kind of collisions would be considered as effective? Shazin, do you know about that? I want to know what kind of collisions would be called as effective. Quickly tell me the answer. Yeah, that would nothing would happen, but there are certain collisions between the reactant molecules. Which collisions would be considered as effective? You read, Shazin, Tawanga, Tawanga. Do you know which reactions would be considered as effective? All right. Let me tell you the two conditions over here which are important for your exam. I'll be writing that. Only those collisions would be considered as effective if they would have right orientation and they would have sufficient energy. So quickly write that down. I'm writing they would have sufficient energy. Just imagine. Okay, I'll just try to explain that. Abdul, Mikheet, I want to see. All right, let's suppose you're going somewhere and someone just collided with you. Would you get angry? You would get angry. So can I say when you get angry, your energy would increase, right? Would you start fighting with that person? It depends on the kind of to the level of anger you got. If the level of anger that you got is your extreme level, you would definitely fight. But if the anger is less, then you're not going to fight. Is that true or not? Exactly. So that happens in case of collision theory as well. When your particles, your reactants are colliding, they tend to gain certain energy because they would get angry. If the gained energy is sufficient enough, then that would result into chemical reaction. Otherwise, it would not. Am I clear? Diffusion would not be okay. Is that clear? Abdul Makid, Abdul Hafiz, Yurid, Shazan, Tawanga. Is it clear? The sufficient energy part. And now we need to talk about orientation. Perfect. Do you know about orientation? I'll try to show that to you in the next slide to get a better idea, and then you can see. Let's talk about the reaction of H2 and I2, giving you twice of HI. When that is happening over there, I'll draw the structure. This is H and H. Whereas on the other side, I would have I and I. If they're colliding, just see, they are colliding. Is this collision in right orientation? What do you think? Say yes or no. Is this collision in right orientation? Would it form HI? Like you can clearly see this hydrogen would collide with this iodide. They're going to collide. They can form HI, but what about the other hydrogen and iodine on the other side? Are they colliding with each other? Are they colliding? Be sure this hydrogen, which is in the proximity to this iodine, they're colliding, but the other hydrogens on the other side, they are not. Just imagine, let's suppose Shazin and Yurid, you're holding each other's hand, whereas on the other side, Abdul Makit and Abdul Hafiz are holding each other's hand. Now what happens? All four of you needs to meet. But it's just Shazin and Abdul Mukit meeting each other, but Yurid and Abdul Hafiz are on the other sides. They're not able to meet each other, right? So they would not collide. The orientation in which this reaction would be occurring would not be fine, would not be accurate. Instead, very good. Instead, the kind of collision that should have been there should be like this in a parallel manner. Just look at my hands in a parallel manner. HH would collide with II. You can clearly see that both the hydrogens and iodines over here would be colliding with each other, and this would result into two HI molecules, formation of two HI molecules. Is the concept of correct orientation clear to you? Could you understand everyone? Tawang, are you listening? Hello, hey Tayab. Is that clear? Right. The next point that we need to move forward would be we need to talk about perfectionism. We need to talk about certain ways in which rate of reactions can be calculated. The three important ways in which your rate of reaction can be calculated. We need to talk about all the three ways. We're doing quick revision of all the topic. Tayab, if it's possible for you to turn your camera on, kindly turn it on. Oh, you would not need to know about that. It's just that the collisions would be happening. For example, if I added some amount of my reactants into the mixture, not all reactants would result into chemical reaction. Some of them would be reacting, some of them might not be reacting. You cannot control it. You cannot control the orientation, but you need to know what kind of collisions can lead to chemical reaction, right? Okay. Now, the three methods in which your rate of reaction can be calculated would be: first method is change in mass, change in mass. The second method is gas syringe method. And the third method is precipitation reaction. Precipitation reaction. I would quickly want to know if you can please explain me what happens in change in mass reaction. Tawonga, if you're not busy, and Tayab, are you there? If you're responding, do let me know in the chat box. If you're not comfortable turning your camera on, you can chat, like write it in the chat box. Precipitation is not rain here, Abdul Hafiz. It's something else. Shazin, do you know about the first part? What happens in the first part of the reaction? Or Tawonga, if you could answer. Yareed, can you answer? What happens in the first part? Okay. Let me just tell you what happens in this case is you would take a container, you would take your conical flask where your reaction mixture would be there. You would put that in a weighing balance. There would be a weighing machine. All right. There would be a weighing machine. And on the top of it, you would cover that with cotton wool. All right, I am covering that with cotton wool. This cotton wool would make sure that if any of the product formed is a gas, that can expand, that can leave, but your other material like liquid or solid reactants or products would not be able to leave your reaction mixture. It's only your gases that can escape. As per law of conservation of mass, your mass can neither be created nor be destroyed, right? Yup, probably yes. We can use it. If you have your cotton wool on the top of it, it would allow gases to escape. Since gas would be one of your product being formed and your product is leaving, the weight would decrease in the weighing balance. All right. If initially it was 100 grams, it might change into 80 grams, which means 20 grams of your product has escaped. How much of your product has escaped? It's 20 grams. Be careful. When 20 grams of your product has been escaped, you would calculate the time taken. So you just need to do change in mass of your product, like change formation of the product is 20 grams, divided by the time taken, probably 10 seconds, 20 seconds, and that would be your rate of reaction. Or you might be plotting graph on that. Yes. 20 grams of the gas that would be produced, which is one of your product, all right? The next one is gas syringe method. In this gas syringe method, what really happens here is your gas would be very light. Gas has very less mass. Very less mass. A very common example for that is hydrogen, that is H2. Hydrogen gas is very less. You cannot measure the decrease in the mass of your reactant if one of the product is hydrogen gas. So in order to calculate the rate of reaction, what you're going to do is you would calculate the volume being collected in the gas syringe. So you would collect the volume in the gas syringe over there and divide it with the time taken, and that would be your rate of reaction. Very good. Exactly, Shazin. You know it. I'm pretty impressed. Very good. Okay. So the next part where we need to move forward is a third part of your reaction, which includes precipitation reaction. First of all, I want you to tell me, Tawonga, are you listening? Could you tell me what is precipitation reaction? Could you type down if you remember it? And others also, if they can type down what is precipitation reaction, quickly answer it. It's not raining, just in case. Quickly, I want to know it. Abdul Hafiz, it's not raining. It's different from raining. Okay. There's a cross that will be disappeared at certain concentration. Yeah, because of the formation of precipitation. First of all, I'll try to explain you what exactly is precipitation reaction. I'll take an example. You took two clear solutions, right? I'm writing A, AQ, which means aqueous, and B, AQ, which means aqueous. There are two clear solutions. Two clear solutions. Your solutions would be so clear, it would be clear as water. It's like you would have your conical flask. If you would see from the top, there would be a cross mark that would be visible to you. All right. Wait, try to listen to me. I'm explaining it. All right. Just have a look. Let me just explain. You would have your reactants over here. There is one reactant A and there is other reactant B. All right. The two of them are soluble in water. So you would have a clear solution of them. When they're going to react with each other, you would see that one of the product being formed is in the solid state. All right. And the other one is in the aqueous solution. Because of the solid product being formed, it is insoluble in water. Since it's insoluble in water, it would be called as precipitate. All right. It would be called as precipitate. And such kind of reactions in which you're getting an insoluble product from two or more clear solutions is called as precipitation reaction. And because of the formation of this precipitate, what really happens in this experiment is that the cross at the bottom, it disappears after some time because of the turbidity, the solid precipitate, which is not soluble in your solution. Am I clear? Is that clear to everyone? You read Tawanga and very good, Shazan. Did you know about, precipitation reaction earlier, about the definition and everything? All right. So let's get started. Oh, okay. So I guess you knew the word now. Now, as per the promise, because on every Saturdays we are coming with different live sessions. So next Saturday would be a live session on VR, that is number letter codes. I hope all of you would be attending it. Hafiz, like Abdul Hafiz, would you be attending that session? And the other session would be on GCSE. That's great, Ivan. Mock test paper two. That's what you would be covering. All right. So please be there on your time. Now, this is the question that you need to attempt. Quickly read the question and tell me how would you attempt it. I'll just tell you how to solve questions. And I'm pretty, strict for Shazin and Tawanga to read the question and give its answers, and Tayab in case if he will respond. Ivan, you too, if you could answer. You read. Abdul Hafiz and Abdul Makid, you all can try this question as well. This is your past year paper question and is one of higher grade levels. If you're done reading this, just let me know. This question is about sodium thiosulfate solution, that is Na2S2O3, and when it would react with HCl, you're going to get sodium chloride, water, sulfur dioxide, and sulfur in the solid state. So the precipitate that I have here is sulfur. All right. So let's move forward towards the question that comes here. Answer this. Sulfur is produced in the reaction. Why does the mixture becomes cloudy? Write your answers. I want to know it. I've explained the whole concept. You know what? The question moves forward. It goes up to grade 8. And you need to be very smart while answering the questions. So try to answer. Tawanga, I'm waiting for your answer. And Shazan, you too. Quickly. Solve it and let me know. Sulfur is produced in the reaction. Why does the mixture become cloudy? Because the sulfur is insoluble, so sulfur doesn't dissolve. Very good, Shazan. Exactly. Because of it being, insoluble in water, it would cause cloudiness into the solution. Now, the next part is that a student investigated the effect of changing the concentration of sodium thiosulfate and to check what would be the rate of reaction. The figure is right there in front of you. There's a light source and a light sensor, because this time the cloudiness would actually tend to stop the light source, the light to pass through it. All right, and he's using different concentration of sodium thiosulfate to see how it would affect the rate of reaction. Look at the experiment that he did. All right, read it carefully, and then you would have to answer. Very good, Abdul Hafiz. That's pretty smart. You tend to learn about it pretty quickly. Looks like you're already GCSE ready. So in this one, a smaller percentage of light from the light source reaches the light sensor as the mixture becomes more cloudy. So less amount of light would be able to reach. The method used was you need to use measure 50 centimeter cubed of this much concentration sodium thiosulfate, add 10 centimeter cubed of HCl into it, and then immediately start the timer. Record the percentage of light that would be decreasing after every 20 seconds till 120 seconds. And you will have to repeat the step 1 to 4 using 0.20 moles per decimeter cubed concentration of sodium thiosulfate. Look at the graph that was obtained. All right, the percentage of graph that was obtained for the solution of sodium thiosulfate, which was 0.10 moles per decimeter cubed, is right there in front of you. They're saying that the percentage light reaching the light sensor decreases by 1%. When these many moles of sulfur are produced, determine the rate of reaction in moles per second for the production of sulfur at 30 seconds. Remember, you will have to draw the tangent. So tell me, how would you do? Let me know how would you calculate at 30 seconds. How would you calculate the rate of reaction? Just describe it. If you would be able to do it, I'll just move forward. I want you to tell me the answer. This is higher grade level question, and this was your past year paper question. Let's see if you would be able to do that or not. The question says that you need to calculate the rate of reaction for the production of sulfur at 30 seconds. At 30 seconds. How would you do it? Just describe the process, describe the method. Do you want to annotate? All right, I'll just describe it. I'll let you annotate. Okay. All right. Oh, Abdul Hafiz, so you know how to draw it. That's interesting. Very good. Exactly. You will have to draw a tangent, but at 30 seconds, that is over there. So I'll draw a tangent. And on drawing a tangent, I would have to calculate the change in value, that is y2, y to y1, like what is y2, y1, and x2, x1. So I just need to do y2 minus y1 over x2 minus x1 to calculate my rate of reaction in this particular case. I hope I'm clear to you. Very good, Shazan. Okay. Now, there would be like live sessions and that we tend to provide from 1 to 1. There would be different live classes, mock test, recorded lessons, and all that stuff available. Rest of the questions, try to do them as a homework. Quickly take a screenshot so that we can move forward towards the next topic. I would request all of you to take screenshots and send answers to me. Raishas and I would be waiting for your answers. Kindly submit them. And there's another question in front of you. All right, Awanga, no problem. Right. Draw a graph, take a screenshot. These are the questions on rate of reaction. Send it to me. I'll definitely check them up. All right. Okay. Now we need to move forward towards our next topic, that is reversible reaction. Shazan, could you take screenshots? I'm so sorry for that. Okay. Wait. Take screenshots. Another one. Another one. Not this one. This one. Okay. Perfect. Now we need to talk about reversible reactions. So first of all, what do you understand by reversible reactions? Do you all know how people tend to drive a car? Do you all know? So when they want to, there's a reverse gear in your cars. What does that reverse gear for? What do you know? What do you think it is for? If you could answer that. Tell me. To move backward. Very good, Shazan. Very good, Iman. So, similarly, when we talk about reversible reactions, it means the reactions that can go forward as well as backward are called as reversible reactions. Now, there are certain examples that we need to remember. The first example is that of thermal decomposition of ammonium chloride. I would want you all to quickly give me the formula for ammonium chloride. Let's see if you know it. Oh, amazing, Abdul Hafiz. You know it already. Very good, Abdul Makid. But I want to know the formula for ammonium chloride. Very good. Okay, I got one answer. What about others? What's the formula for ammonium chloride? NH4Cl, exactly. So your ammonium chloride would be NH4Cl. Let me just show you. NH4Cl, which is in the solid state, would go in the forward as well as in the backward direction, and it would dissociate into ammonia, which is a gas, and it would dissociate into HCl. You know what? The products are very important. There was this past year paper question where they were given different options and you needed to choose what are the products. They said ammonia plus chlorine gas, like ammonium ion plus chloride ion. That's how they tend to, confuse you students. So you should know that is ammonia and HCl that was actually formed. Right. Now, thermal decomposition. Could you tell me the meaning of the word thermal? What does that mean? What's thermal? What do we understand by the word thermal? Heat, sunlight, or heat. Exactly. Sunlight would be the right one. My bad. Heat would be the correct one. You're providing heat to it. Sunlight can provide heat, so you can call that, but therm is basically related to heat. And what do you understand by decomposition? Quickly write down. What do you understand by the word decomposition? What do you understand by the word decomposition? When something breaks down, breaking down. Okay, a lot of people know about it. Very good. So you're basically breaking down something with the help of heat, and the one that is being broken down is ammonium chloride. Now, you tell me when you talk about the forward reaction, since you're giving heat to it, is it exothermic or endothermic, in case if you know it? What do you think it is? Is it exo or endo? Perfect, Shazin. You're pretty smart. Okay, exactly. So if I would go back, I need to write that the forward reaction would be endothermic. If my forward reaction is endothermic, what about my backward reaction? Is it exo or endo? The backward reaction in such cases would be opposite, that is exothermic. All right, very good. Now, the next example is that of dehydration of hydrated copper sulfate. First of all, I would want all of you to tell me color of copper sulfate. You might have seen copper sulfate somewhere. What color it has? Exactly. I would want to know the formula of hydrated copper sulfate in case you know it. Yeah, it's blue. It's blue, it's blue. It's not orange. But that's just copper sulfate, Ivan. I'm asking for hydrated copper sulfate. What's the formula? Let me write that down. It is CuSO4 dot 5H2O. There are 5 water of crystallizations that you need to remember. It's very important. How many H2Os? You knew H2O, but you did not know a number of H2Os, right? That is hydrated copper sulfate. If you're going to heat it, you would get copper sulfate, CuSO4, and those 5 water molecules would get evaporated. Due to this reason, the blue color of copper sulfate would fade away and it would turn into white. I have a question. Between copper sulfate and 5H2O and copper sulfate, one of them is in the powdered form and the other one is in the crystal form. So I want to know which one are the crystals and which one are the powder. Which one are the powder and which one are the crystals? Just in case if you know the answer, you can let me know about that. Okay, hydrated is powdered. You need to be careful. You know what? The one in which hydrated is there, that would be crystals. So you would have blue colored crystals of copper sulfate. It's very important for higher when you would move towards higher. These five water molecules, they're water of crystallization. These water of crystallizations tend to give structure to the crystals. Then the crystals form because of these water molecules surrounding them. When these water molecules leave them, they end up being just powdered. They're just powder. That's it. So that's what you need to remember. Many times, a lot of students do not know about this. So you need to be very careful about it. Very good, Ivan. Okay. Now we need to talk about dynamic equilibrium. So who knows about what dynamic equilibrium is? Right. Could you tell me, if you could tell me, let's see, there are certain points which you need to write. And you know what? If you would love to choose, chemistry in higher as well after GCSEs, this definition would still stay the same with you. It wouldn't change, but you need to know what it is. An equal amount of energy, just energy. All right. I'll tell you. Okay. So let's take one example. Abdul, Hafiz. All right, listen to me. Let's suppose you're moving on an escalator, okay? You're just going up on an escalator, but you're moving. But the stairs of that escalator is moving down. All right, you're going up, but the stairs are actually automatically coming down. The speed at which the stairs are coming down and the speed at which you are moving up. If both the speeds are equal, so could you tell me where would you go? Would you go up, down, or where? This question is for everyone. Tell me, where would you go? If the speed at which stairs are moving down and the speed at which you are moving up, if both of them are equal. Exactly. Very good, Ivan. Very good, Shazan. You would stay the same. Very good, Abdul Hafiz. You don't go anywhere. Or Abdul Hafiz would not go anywhere. He would just stay on the fixed position. That's what dynamic equilibrium is. Do you know what? When you talk about the word dynamic here means something in motion. And equilibrium would mean when it's not changing. Nothing is changing. Abdul Hafiz's position was not changing, but not everything was at rest. He was moving, stairs were moving, there was motion, but still nothing was changing. That's what happens in case of dynamic equilibrium. So if you would have to, in that case, you would disturb the equilibrium. That would not be in dynamic equilibrium, right, Abdul Hafiz? Your dynamic equilibrium has been disturbed. In a closed system, there are certain points that you need to write. In a closed system, the rate of forward reaction would be equal to the rate of backward reaction, that too in a reversible reaction, due to which the amount of reactants and products would remain constant. Things are not changing, but still your reaction is moving. That's what it is. And these are the points that you need to write in the paper. Yeah, you would go down in that case, and you would not be in equilibrium. Your reaction would be, you would not be reversible, right? You're just moving in one direction, Abdul Hafiz, in that case. Let's talk about Lee Chatler's principle. So, who knows about Lee Chatler's principle? Lee Chatler's principle. All right, everyone. Let's say that I am at equilibrium. My position is fixed. If someone from this side tends to push me to the other side, I want to come back. In which direction should I push myself back? Tell me, left or right? Is it left or right? Where should I push myself back? Left, exactly. So basically, if someone disturbed my equilibrium to the other side, I'll try to come back in the opposite manner. That's what Lee Chatler principle says. Lee Chatler principle says that disturbing a system at dynamic equilibrium shifts the equilibrium in the direction to counteract the change. All right, it would shift the direction to counteract the change, that is to the opposite direction. Now your dynamic equilibrium can be disturbed by change in concentration, by change in pressure, and by change in temperature. Change in temperature. Do we have any effect in the position of equilibrium by using a catalyst? Would we have any effect on that? Yeah, it is like friction. You can consider that. But we're talking about reactions, right? So you will have to talk about reactions right now, going forward and backward. Okay. These are the factors that that we tend to talk about: effect of pressure, effect of concentration, effect of temperature. I'll be asking certain questions to you. You have a reaction, A gas plus B gas, which is in equilibrium to give you C gas. If I'm increasing the pressure, I want to know in which direction my reaction would shift, my equilibrium would shift. Tell me if you can answer it. On increasing the pressure, in which direction my equilibrium would shift. Not towards A plus B? Is it towards left or towards right? C. Very good. Very good, Shazin. Very good. It would move towards right hand side. And if my pressure decreases, in that case, it would move towards left hand side. So you already know about these effects. Let's move forward and try to have a look at the question. Quickly, so look at the question, read it, and let me know if you could solve the question. Okay. Name a suitable piece of equipment to heat the tube A. How do you think so I can heat the tube A? Where's my tube A? This is my tube A. How would I heat? Name a suitable, like equipment for the same. Bunsen burner, very good. Very good, Abdul Hafiz. Now you need to talk about the color. Hydrated copper sulfate, what color it has? And anhydrous copper sulfate, quickly. Blue, and the other one is white. Very good. Very good. I'm pretty impressed. Very good. Okay, what purpose of using ice and water in the beaker is? Could you tell me why are we using ice and water in the beaker over here? Condensation. To lower down the temperature or for the condensation to occur. Very good. All of you are correct. I'm pretty impressed. Very good. And drops of clear colorless liquid formed from like on the inside of the tube B. Name the liquid that would be formed. Which liquid is being formed here? Which liquid would be obtained on this side? Exactly, very good. You people are doing very good. It's water because it's the clear solution. And explain how liquid came into the inside the test tube B. How do you think so it reached? How do you think so it got reached? You just need to explain it in two important terms because the question is of 2 mark. It was there as water of crystallization, but the question is of 2 mark. You would say that the water, like water molecules in hydrated copper sulfate, water of crystallization, got evaporated. And after evaporation, it was collected in test tube B by the process of condensation. So first evaporation and then condensation. That's what happened here. All right. That's how you need to write your answer. The question is not about equilibrium, it's about reversible reactions. Read the E part and try to answer that. Anhydrous copper sulfate turned into hydrated. What would you need to add apart from the change in color? What could you observe? You need to add water, and what would happen in that case? Apart from color, what other observation would you observe on adding water into it? Let's see who can answer this. On adding water to anhydrous copper sulfate, what would happen other than change in color, other than it changing into blue? Not crystals, no, that's not the observation. Like, think of something else. heat would be released. All right. Because the backward reaction would be exothermic, so heat would be released. That's the second observation that you're going to observe. Yeah, it's exo. All right. Because the backward, it's not seen, it's observed. They're talking about observation, right? So you're observing it. The rest of the questions would be your homework. Try doing them and take a screenshot. I would want all of you to do the 6 marker question as your homework, if you would be able to do that, right? Okay. Your admissions are open for 2024-2025. If you're interested, you can get yourself enrolled. They're 20% off for first 20 students over there. Right. Now we need to talk about crude oil. What exactly is crude oil? Let's cover a bit idea about it. What is a crude oil? What is a crude oil? Oil from the ground. Very good. Exactly. Or oil from the, like from the sedimentary rocks, you would tend to obtain that. And it's basically dark and smelly color liquid. When it comes into this particular chapter, you have to mention that it is mixture of different hydrocarbons. Now my question comes, what exactly is hydrocarbon? It's very easy for you to remember the definition of hydrocarbon. Like I'll write hydrocarbon. Hydro would mean hydrogen and carbon would mean carbon. So the compounds which contain only hydrogen and carbon in it would be called as hydrocarbons. All right. There are two basic types of hydrocarbons that you would have to learn in this particular case, which is alkanes and alkenes. So I would want to know if someone would know about the general formula of alkane. What's that? Very good, Abdul Makid. Can someone tell me the general formula for alkane? What's that? It's not CnH2n, it's CnH2n plus 2. Quickly write, you need to know about the basic definitions. Alkanes would be CnH2n plus 2. And if I would talk about alkenes, the general formula is CnH2n. To know about hydrocarbons in much detail, I would love that all of you would come into the sessions and learn chemistry all together so that we can cover all the topics in detail. Very good, Abdul Hafiz. Okay. Before ending the class, I have a question. All right, if you could try this. Let's see. Can someone explain how fractional distillation occurs? Do you know the method of fractional distillation? This is 4 mark, and this question has been repeated in the papers in most of the year's papers for 4 mark, 3 mark, 5 mark. Would you do this? Would you solve this question and send it to me? Shazan, I hope you have the contact details of the team, right? Would you send all the homework? Do you know my name? Just in case you do not, it's Ria, all right? So let's move forward. It's Leva. And if I would I would say that I thank you so much. And in case if you have any questions, do let me know. My name is Leva, just in case you would have any doubts. Very good. But I need a 4 marker question answer. All right. Do you have any doubts? Okay. So that's it for today. Till then, take care, everyone. Bye bye.